Thanks everyone for joining us today. We've got a really interesting paper reading. We're going to be exploring DeepSeek, their recent releases of, DeepSeek R1, as well as just R1. I'm Sally Ann. I'm a product manager here at Arise. And with me today, I have Nick. You want to do a little bit of an intro?
Yep, I'm Nick. I'm a solution engineer here at Rise, so I work with our LLM clients. I'm happy to kind of talk a little bit about the DeepSeek model today.
Yeah, Nick's been playing around with some different experiments with it. Towards the end, we're going to get into actually some code, show you some differences, which I'm really excited about. We love this to be interactive. So as we go around, we're going to first kind of do our AI industry updates, and then we're going to do a little bit of an intro to DeepSeek, go through some of the key highlights of the paper. Definitely recommend you reading through the paper, trying out the repo. But today we're going to kind of hit all the highlights. Feel free to drop any questions in the chat as we go along. Cool. So just kind of starting here with some AI industry updates. So OpenAI released their Deep Research. It's a new AI tool for autonomous search. It's been getting a lot of attention. It is a little bit expensive to try, but if you can try it, I definitely recommend giving it a go. It uses some upcoming O3 reasoning model that they haven't quite released to all of us, but you can use it in Deep Research. So I think this is definitely the biggest news that we've seen in the last, 2 weeks. The other one is DeepSeek's training costs question. So if you were here on our last paper reading about 2 weeks ago, I kind of put up here the announcement of DeepSeek. I've talked about the training costs, but now some folks are questioning it. It seems like the 0 to R1 is what that $5 million estimate came from. So still a little bit unclear exactly what the cost was, but it's just interesting to kind of see how things have changed a little bit now that it's been out for a little longer. Another big piece of news coming out of AI is this big text AI spending surge. So I'm not sure if everyone's seen it, but Amazon, Google, Meta, Microsoft, they all spent like kind of a cumulative $300 billion on AI infrastructure, really seeing a continued investment in this space, which I think is exciting for all of us here. Last item here, AI goes mainstream. So Super Bowl art, music. If y'all were watching Super Bowl on Sunday, you might have noticed that OpenAI, Meta, Google, they all ran major ads, which was really interesting to see kind of go into the mainstream, having these commercials for their chats, which was cool to see. There was also some things in some other areas like art and music. So there was an art auction that had a little bit of backlash. Some artists were protesting AI generated art. There's some ethical concerns, but just really an interesting debate going on about AI generated art. And then at the Time 100 AI Impact Awards, Grimes won a award for AI music. So just really interesting to see how AI is kind of slowly creeping into all of our mainstream areas. So yeah, really interesting week for AI. Let's get into the paper a little bit. What is DeepSeek? So our DeepSeek R1. So it's a new AI model for better thinking. So the goal was really to improve reasoning skills using reinforcement learning. So we might refer to that as RL throughout this PowerPoint here or through our presentation, but this is a little bit different than what's done like previously. There's been a lot of kind of supervised fine tuning for a lot of these reasoning models, but they took a different approach with using reinforcement learning. So they have DeepSeek R10, which is trained only on reinforcement learning. So there's no pre-training there. And it showed some strong reasoning skills, but there were some issues, and we'll probably get into that a little bit later. And so from that, they kind of learned, and then they adjusted to just DeepSeek R1, which is kind of this improved version with a little extra training. So a little bit of supervised fine-tuning happening before the reinforcement learning. So this did show that it actually fixed some of those language issues and did reach some pretty top tier performance. So taking a look here, this is one of the visualizations from the paper. I think the main takeaway here is it's pretty competitive, the results. That kind of dark blue stripe, that's going to be R1, that final model that had a little bit of supervised fine tuning along with the reinforcement learning. And you can see it's pretty competitive against that gray, which is going to be OpenAI's O1. In some places you can see even like math, it surpassed it, as well as I think in this AIM data set here. So really promising. They were able to show that there is a feature which we don't need just to use supervised fine tuning, and I think really set the gold standard of what these reasoning models should be capable of doing. Last slide here, I want to kind of just talk through before Nick kind of gets into the details and shows you all the exciting stuff here, is the breakthroughs in reasoning. Like, why does this matter? Reasoning is a fundamental aspect of human intelligence. And as we kind of try to chase AGI, this is going to be something that we kind of continue to come back to. Even as we were talking kind of in our last paper reading, we talked a lot about reasoning and why that's so important and why there's continued research into this. So this breakthrough just kind of seems like it's one step closer to getting even better reasoning. And it's really key for solving any kind of tricky problems. I think in the agents world, it's really important to have good reasoning, especially as we get more and more complex with the tasks that we're expecting these models to be able to complete. So that's kind of why it matters. We are still continuously chasing AGI. I think that's what everybody's kind of set as the next standard of a breakthrough. And that's the ultimate goal, I think, for some people, maybe not. But for a lot of the community, they're trying to see how close we can get. And so this is a really great line of like, LMs are super smart parrots right now. They can talk, but they don't really actually understand. They're kind of just like regurgitating information that they've been trained on. But as we get to reasoning, we're going to be able to mimic kind of that human intelligence better and better. And that's kind of how we'll eventually get to that artificial general intelligence. So interesting time, really excited to kind of see this breakthrough. But Nick, I'll pass it to you so we can kind of get into the actual technical details.
Cool. Yeah, so we'll start by talking a bit about R1, R10, which is that pure reinforcement learning trained model. So essentially what went on here, right, is researchers from the DeepSeek team set out to build a model without using any supervised fine tuning. So they don't want any humans involved in this, right? Just purely a reinforcement learning process. They used a pretty interesting approach here where they created a reward system that rewarded on two major features, essentially accuracy of the question. So if it was asking a code question, right, using a compiler there to say if it was right or wrong, math question, right, using kind of more deterministic methods to figure out if those were correct, and then feeding those back to the model. They also used a feature for format, so enticing the model or driving the model to use those thinking brackets that if you've used the model at all, any of the DeepSeek models, you'll know you see those little like thinking tags in there. So they use these as the reward system, tell the model when you're right, good job. If you format it, with these thinking brackets, great work. And then they use that in the training process. As they go through that training, right, as they're feeding that back into the model, they observe these, what the researchers call aha moments with the model, where DeepSeek R1 is actually trying to solve a problem. It'll kind of get halfway through the solution and go, wait, this is actually incorrect. I need to go back and do X, Y, Z. And this is something that had not happened in previous models before, right? The model is kind of self-correcting itself in that thought process, which is an aha moment for the model, right? It's like, oh, look what I found. I found a mistake, but also for the researchers to see the model actually being able to do that on its own. The model was, if you check the paper out, there are some pretty interesting graphs about the test time or test inference compute there, where the model is just on its own figuring out that it needs to spend more tokens for more complex problems, and will spend that additional time trying to figure it out before it gives that final answer. So pretty interesting from kind of what we've seen in the past.
I think that was one of the more interesting pieces of, I think you've seen the reasoning where it's like completely wrong in like some of the other models, but it just keeps going with it. Like you never really see that point of like, oh wait, that's wrong. And the like recourse that it takes and just goes in the new direction is really cool to see.
Yeah, super interesting to see kind of it, right? It's self-correct to an extent, right? It's going in there and figuring out that it made a mistake and fixing that. Yeah, great question on the language mixing issues. So when we're using reinforcement learning, right, we don't have a human in there kind of telling it, yes, this is good, no, it's not. So the model's just doing what it needs to, and the model can understand multiple different languages. So what the researchers were noticing is sometimes the model was switching from English to Chinese, to Korean, right? Well, a bunch of different languages that were going into the model training set were getting used in the output. The readability was not great in a lot of those outputs because it had no kind of base there to drive it towards a human readable output. So what they did was they decided that they were going to try and train R1, which is probably the one that you've used at this point. So if we go to the next slide there, we can take a look at how they kind of dealt with that like language mixing problem and some of the readability issues. So that the big focus of the R1 training run is to improve readability and keep it in a kind of single language when it's talking. They choose a language based on where you're based. So if you're speaking in English, the goal is to get the model to respond completely in English and add a little bit more of that reasoning capability in. So they took a pretty novel approach here, which is a multi-stage training pipeline for this specific use case. They essentially start with a very high quality data set that's fine-tuned towards the RL process. So they give it a nice base of reasoning in that cold start. Then they run it through some reasoning-oriented tasks, and they use reinforcement learning, that accuracy and format reward system, to actually, ask it some coding questions, math, science, logic, run through all of those. I think in the paper they mentioned the data set, the initial data set is about 800,000 examples that they're using. So pretty large data set there that they're training that on. From there is a bit of supervised fine tuning that's going on with R1. So it's not completely reinforcement learning like the zero model is. The researchers, gave it examples of good human responses, right? Keeping your answers all in one language, formatting those answers nicely to make it easier for humans to understand. So they run through that rejection sampling and supervised fine tuning. And then finally, they kind of give it a final RL run where it's just running through a bunch of different scenarios, both coding, math, logic, and then general like human back and forth conversational type questions. So that all kind of gets bundled up into a single pipeline, and that's essentially how that R1 model was trained. Paper goes into far more details. If you're interested in the math of how that was done, you can certainly check that out. DeepSeek Math is also a great paper to look at if you are interested in the actual math and how they figured out how to do all that. So both of those are valuable if you're interested there. But the high level of it is these 4 steps that they ran through to kind of to fine tune that model for human usage.
Super interesting. And it pays off, right?
Certainly, right. If you're able to compare that 0 to R1, you'd certainly see a pretty big difference. What's actually interesting, they call out in the paper, is when they went from 0 to R1, they, especially around the language mixing piece, they actually lost a few points on some of those benchmarks. So the model performed better when it was able to mix languages in there for some, for whatever reason in the internals. But we as humans need to prioritize the ability to actually understand those outputs, or there's no real value if you can't understand what it's saying.
Totally. I think that's it's a trade-off we see all the time is these models are mostly being used for obviously like human interaction. And when you get into like the business world, that's customer kind of interaction. So we're kind of always optimizing around that, even though there's been things where it's like, oh, this performs really well, but it takes forever to produce a response. Like that's not going to work. Or the mixed language is like that actually produced a really good response, but no customer or user is going to be able to really, just overlook the fact that it's responding in 2 different languages. So it's kind of interesting how there's like this technology piece where we're constantly trying to push what the models can do, but then we're also always anchored to this like user experience, which I think is kind of an interesting paradigm there.
Yeah, and that's a great segue into kind of the next step that the team took here, or the DeepSeek team took. They realized that that model, right? The R1 model is huge. I think it takes 700 or some gigabytes of RAM to actually run that. So you need a massive machine to run that locally. And their goal was to open source all of this and allow everyone to run the model, use it as they'd like to, fine tune it as they like to. So what they did was they went through a process of distillation. And essentially what distillation is taking a bunch of outputs from that R1 model, the 0 model, and using it to teach a smaller, more efficient model in the same sort of reasoning process. Right, so we can take a 1.4 or 1.5 billion parameter model, a 14 billion parameter model with some different architecture, train that on the outputs of R1 and get similar performance. In a minute, we'll show a quick demo of actually running those locally, so you can check out how that works as compared to one of the larger models. But it's super interesting that we can take I think it's 671 billion parameters in the full-sized R1 model, distill that down to 1.5 billion and still get pretty good scores on math and different coding challenges, and even get like coherent responses as you're chatting with it. So I think that's probably the big breakthrough there, is being able to train these models and then shrink them down and kind of make them available for everyone to run.
Totally. I'm a big fan of the small models. I really think that those are going to be the future in terms of like actual applications. These big models might be the future of like AGI, but the small models are the ones I think that will move closer and closer to actually using in our applications. So I think this is really important.
Yeah, and then there's a question in the chat there about that grouped policy optimization process. They dive very deep into the ins and outs of how that works in their DeepSeek math paper. So happy to send that over. I think that one is probably worth like an entire session to talk about the difference between that and the standard PPO. But definitely worth, if you're interested in the math there, worth taking a look at that paper. They do a great job of outlining everything that's going on in it. Cool. I think from here, probably worth jumping into a demo.
Yeah, let's do it.
Awesome. So what we've got going on in the demo here, let me pull this up and show my screen. Second. Okay. So I've got a Streamlit app here, right? Nothing too interesting yet. But some of the callouts I want to make before we get started. I am using the Olama tool from Meta to actually serve these models locally. So I've downloaded a few of the distilled models to my machine here. I'm running this on like a standard M3 Mac, might be a Mac Pro, but still, right? Nothing crazy, nothing too advanced that this is being run on. So I've got a couple different models that we can test out here today. We'll start with that 1.5 billion parameter model. That's the smallest, most distilled version that they've got. Essentially, I've just got it into a Streamlit app here to make it easy to interact with it. And then we've also got Phoenix running at the back end to kind of collect some of the open telemetry that's getting generated from my application, so we can see some timings and maybe see some of how that model is actually doing its thinking. So the big value or the big goal of the DeepSeek models was to train some math, in the ability to do math into the models. So you can probably start with just a math question here. Very simple, right? We're just going to do addition for them. We can say, what is 10 plus 25? And it'll take a little bit of time to run, right? Because I'm running this locally. It is just running off the power of my machine here. So we'll give it a second to run. And there you go. So, right, 10 plus 25 is 35. Did a good job there. Pretty simple question. You can see some of that breakdown of how it's actually thinking through that. And then we can take a look at the reasoning step. So some of these smaller models will kind of just run on their own, right? They'll kind of really get to thinking. And you can notice some of those aha moments going on in this thinking. Right here, right in that in this highlighted section, you've got that wait, but just to double check. So the model's kind of thinking there, hey, I need to take a look back at what might be going on. And then it's kind of thinking through this math problem. Fairly simple problem, but a ton of tokens required to get that response. And then we spit out that answer. Pretty interesting to see how it's kind of doing that math. Maybe that's how you do the math in your head, maybe not. But that's how DeepSeek decided to do that one. And then if we take a look at Phoenix, right, we can see in here the kind of all of that information for us. We can also see that some of that latency, which is pretty important if you are looking to run something like this locally. How much latency are we going to deal with? How long is it going to take to actually run this? So right, pretty interesting output. But what's nice about the open source models is this is all running locally on my machine. If I were to turn off my internet, I could still interact with this model. I can still use it just like I was connected to the internet. There's no data leaving my machine. There is no third party involved in this in the data transfer here. So you can really be sure that all of this data is yours, right? It's not going out anywhere, which really makes this makes it pretty cool. Also have the ability to fine tune these if you'd like to. Since the weights are on my machine now, I can go in there and fine tune as I need to. I don't have a fine tuning pipeline set up right now, but maybe maybe a future project there. We can also take a look at how the 14 billion model, billion parameter model performs as compared to that 1.5 billion. So I'll just clear this chat real quick, and then we'll ask it that same question and see how it performs. All right, I think I did 10 plus 25 last time, but you get it. You'll notice here, because we are now, instead of running through 1.5 billion parameters to get this answer, we're running through 14 billion. Model sizes here, I think the 1.5 is about a gigabyte in size. This 14 billion is about 9 gigabytes, so considerably larger in size. So it's going to take a longer period of time to run there. We'll give it another second to pop out. Live demos are always interesting, but you can kind of see, right, like very clearly this is taking considerably longer. So when you're thinking about performance versus performance of the model versus performance of your application, you really want to look at the size of the model you're running, the size of the hardware that you've got to actually serve that up, and then take that from there. This is running, but it's just kind of thinking through this one, really turning those gears.
Give it a really hard math problem there.
Yes, yeah. So as you can see, right, local is fun to kind of play with. Yeah, there you go, right? Took about, let's see how long that actually took. So it took about 70 seconds to spit that out versus 13 seconds for the billion parameter model. So maybe this isn't the best use case for a local model, but it is interesting to kind of see how all of that thinking happens and how those models are producing those answers.
So cool.
Cool.
Let's see. Any other gotchas, Nick, that like as you were kind of playing around with these that you were surprised by when you were doing it, or was it difficult to get started? I know like on the GitHub page, they're like, if you're doing local deployment, make sure you read this, and they list out like a kind of a few things to be aware of. But yeah, anything the audience should be thinking about?
Yeah, I think system resources are going to be like the number one thing you should consider when you're doing a local deployment. Olama, just not to plug them too much there, but they make it very easy to get those models onto your machine. But at that same time, right, it is easy to pull a model that might be too big for your machine, fill up that storage pretty quickly. So just make sure you're reading, how large that model is before you pull it down with Olama. And then just making sure you're maintaining those system resources as you need to. Some interesting stuff with these models. They have a kind of an interesting personality, so you can really kind of get them to do some funny things. So playing around with it, right, has been a lot of fun as compared to some of those bigger, more professional, so to speak, models. So if you're in there and getting it to kind of tell stories or do things like that is pretty interesting.
Yeah, not as much red tape on these models as some of the other models that we've worked with so far. There's a question from the audience here. Have we seen companies using DeepSeek models in prod? I think it's too early. Like these models have only been out for like a few weeks. I do know of a few companies who are at least testing or curious whether that actually makes it to prod or not is I think a totally different discussion. Every time you switch a model, right, there's prompt changes, there's really a lot of like experiments you have to set up to make sure that everything works. So I think it's going to be a little while before we see anybody just putting a DeepSeek application into prod, but something that I imagine we will see folks shift towards, especially if they really need a lot of reasoning there and they want something that's open source, which is a big benefit for anybody who has kind of like those privacy concerns where they want full control over the model. Good question. I know we're wrapping up on time, so if any have any last questions for us here, feel free to drop them in the chat. But I think this is really interesting. I think it's fun to kind of see this new model. We've kind of been seeing the same iterations of models from different providers for a while now, so it's been cool to see something new. But yeah, Nick, any final thoughts on DeepSeek?
I mean, I would definitely take a little time to play around with it. Definitely
Yeah.
worth a couple hours of your time to mess around. It's definitely a different experience than what you're used to if you are, using a Claude or an OpenAI model. And I see that shout out in the chat for Streamlit. Yeah, that is, that's my go-to for you for UI stuff. I stay away from the UI build too much. But as you got some time, right, play around with it. Is like I said, it's definitely a different experience than probably what you're used to.
Totally. It's really interesting. I see a question too about using like these DeepSeek models with LangChain. As far as I know, I do believe that they have a LangChain. LangChain does have a DeepSeek module. I'm not up to date on exactly which models you can access from there, but I'm pretty sure they do have a module that you could import from. Oh, we got lots of good questions now. They're all coming in. Potential use cases for DeepSeek 1.5. I think there's a ton. It's hard to kind of narrow down, but Nick, any specific ones that come to mind as you were kind of playing around with the 1.5 model?
I think that the small ones are probably pretty interesting for like some of those traditional ML use cases that we've seen in the past, like sentiment analysis, topic modeling, things like that, that are, have in the past taken a couple weeks to train a model on, right? You need a large data set and you do all that stuff, and that are not complex enough to warrant the use of a 4.0 mini or something. Those 1.5 billion parameter models, I think, probably would be great there. They're also fairly easy to fine tune because they're pretty small. So if you had a specific use case and you wanted to fine tune that 1.5 billion parameter model down to that very specific use case, probably fairly easy to do. I mean, certainly easier and cheaper to do than a 4-hour or a huge model like that. So I think there are, lots of options there. But yeah.
Yeah. And one last question here, I think, is they want to know if you think it's smart enough to run as an agent in a local server. And I imagine like for some things it would work, but like there's going to be limits to that. The local server, I think, might be your most limiting factor. But what do you think on that? You think it's good enough to build an agent with?
Honestly, probably not from a tool calling perspective right
Okay.
now. I don't think the 1.5 size models are in their current state are fine-tuned for tool calling yet. I think if you did some fine-tuning for tool calling, it might work. But it like just playing around with it, it does have some trouble like following directions that are put in the system prompt even. It'll kind of
That
just
won't
do
work for an agent.
it. Yeah. So maybe a little tough. But I bet the 14 and maybe even I think the next one up is 70. Those would probably be pretty good from a tool calling perspective, but I haven't really tested it too much.
Interesting. Well, maybe that's another experiment we'll have to run and post the results for the community to see. But this was really fun. Thank you all for joining. And Nick, thank you for walking us through and showing us your project there. It's super cool to see. And yeah, it was great to see it. Thanks so much.
Yeah, thanks all. Have a good one.